Alright, this video is about the midsegment of a triangle. So basically, by definition, a midsegment of a triangle is a segment that joins the midpoints of two sides of the triangle. Every triangle has three midsegments, which form the midsegment triangle. So if I look at a triangle, any triangle, if X is the midpoint of QP, then these two parts are congruent, and Y is the midpoint of QR, so that these two parts are congruent. The XY is the midsegment. Then if I look in this direction, if Z is the midpoint of PR, then these two parts are congruent, and YZ is a midsegment. And if I connect those 2 points, you have another midsegment. This is called the midsegment triangle, the one in the middle. There's a lot of nice properties to know about these. If these are midsegments to a triangle, then this segment is parallel to the segment opposite of it. It's parallel to one of the sides of the triangle. There's only one side it can be parallel to because it's connecting 2 points here. So it's parallel to the third side of the triangle. So I also know that this line is parallel to this one if it connects those midpoints. And for that matter, this third side will be parallel to this third side. Which is really nice to know because parallel lines give you congruent angles when you find corresponding ones or alternate interior ones and so forth. So that's true about midsegments. What's also true about it is this segment XY is not only parallel to the side opposite of it, it's also half its length. So if I knew this length was, say, 100, I know XY would have to be 50 because the segment, the midsegment, is parallel, that is half the length that the side is parallel to. If I knew, say, this side was 70, I know the side it's opposite of has to be 140, and these are side lengths. Or if I knew this side had to be 30, and the side opposite of it, the one it's parallel to, would have to be 60, because the mixed segment is half the length of the side it's parallel to. Alright, so it's nice to know. I know one thing though, that the perimeter of these things are related. It looks to be all the sides are half the length, so the perimeter is half the size. So whatever this perimeter is half of it. Also the area is half the size. Whatever this area is, the area here is half that area. That's one nice fact about midsegments and the midsegment triangle. Alright, let's go further. Alright, so what I did was I measured the length of this side and I measured the length of that side and I found the midpoints. So I measured this side to be about roughly 6 centimeters. This side I found to be about 6 centimeters. So I marked it about 3. I measured this side to be about 4 centimeters. So I tried to mark that about 2. And I connected 2 dots, making a midsegment. So I know that these 2 parts are congruent. These 2 parts are congruent. I know these 2 lines will be parallel. And also I know this length is half of that one. I can measure it, but I can prove it too. Alright, let's put that to use. Alright, so they gave me this information and they said that CD is a new bridge being built over a lake as shown. Find the length of the bridge. So this is the lake and this is the bridge, CD. And they said these 2 parts were congruent by showing me my picture. And they didn't say these 2 parts were congruent, but they said they're both 963 feet. So I know they're congruent. That means the bridge is a midsegment. So if that's true, I know this bridge has to be half of 2640. So half of 2640. So CD is 2640 divided by 2. And that should be 1320 feet. So that bridge is 1,230 feet. The second question, It took you a step further, and they said, how long is the bridge in miles? Since there's 5,280 feet in a mile, this bridge is shorter than a mile. So it's basically the part that we know over 5,280 miles. And you can call that a decimal if you want, but it's roughly that many miles. I call it a decimal. It's about 0.25 miles. So it's a quarter of a mile. So that's one way we can look at it. We can look at it other ways too. All right, so in this problem, it says in a isosceles triangle RST below, RS is congruent to RT. So these two lengths are congruent. I'll just put a dash right here through the M. And they said that M and N are midpoints. So M and N are both midpoints, making this part congruent to that part. And since both segments are congruent, if I took half of the same lengths, they should be congruent. Right? So like if this segment will say 10, that would be 5 and 5. But if they're congruent, this is also 10, and that also would be 5 and 5. So all parts there are congruent. And then it says if MN is 3.5, so this part is 3.5. And the perimeter of RST, the bigger triangle, is 25. Right, P for perimeter is 25. Determine and state the length of NT. So NT is this part here. All right, when you think about it, it might sound like a lot, but let's go for what we know automatically. What we know is that this is 3.5. We know this has to be 7. So I know that's true. What we also know is the perimeter, that these two sides are the same. Let's call it X, let's call that X. I know this length and that length have to be equal to each other. So I know the equation I can write is 25, the perimeter, is equal to this side plus this side plus this side. So that's 2x plus 7. So now the perimeter has to be 2x plus 7, or 25. If you solve that, subtracting 7, you should get 18 equals to 2x. So you divide by 2. 9 should equal to x. So the missing sides are 9 apiece. So it asks you to find NT, which is this piece. If the whole thing is 9, each piece there has to be 4.5. So I know NT equals the 4.5. One last question. Now let's solve a couple more. This is my last two. In this one, it gave you this triangle, and it said all these are midsegments. So Q and R are both midpoints. We'll say all these are congruent. So Q and R are both midpoints, and this is your midsegment. So I know these two parts are parallel. I also know that this length is half the other. Because of that, I can make an equation. I could say that twice this equals to this side. Or, so I could say twice 2x subtract 3 equals to x plus 3, x plus 9. So or you could have said x plus 9 equals to 2x subtract 3 divided by 2. Most people are not crazy about fractions. So because of that, you might want to just multiply one of the sides by 2. Instead of using this one, you might like the first equation better. And this is x plus 9. So this means that 4x subtract 6 should equal to x plus 9. And finish solving that for x, you should get 3x subtract 6 equals to 9. So 3x equals to 15. And x would have to be 5. So that's one way you can create the equation. In the second problem, which is number 10, it gave you, again, this is a midsegment because all these parts are congruent to each other. So there's midpoints. So I know twice the midsegment. So 2 times the midsegment equals to third side of triangle. So 2 times the midsegment equals the third side of the triangle. So twice that equals to x plus 29. So I know 2x plus 38 equals to x plus 29. And solving that equation, you can subtract x from both sides. So x plus 38 equals to 29. Subtract 38. X is a negative number. X would be negative 9. And that could be, okay, if I plug in negative 9 there, that's a plus 19 right here. So if I plug in negative 9 there, I get a positive number. I plug in negative 9 there, I get 20. So I get a positive number. So it doesn't give you weird links like negative links. So that's a reasonable answer. So anyway, so that's it. That's how they work. That's all I have. Good luck. All right. Hope that makes sense. That's all I have. Good luck.